Friends, welcome to my channel. Friends, if you are new, then please subscribe the channel and hit the bell icon so you will get notifications on my next video. Today's topic is thermal power plant.
Introduction of thermal power plant.
A thermal power station is a power station in which heat energy is converted to electric power. In most of the places in the world, the turbine is steam driven. Water is heated, turns into steam and spins a steam turbine which drives an electrical generator. After it passes through the turbine, the steam is condensed in a condenser and recycled to where it was heated. This is known as a Rankine cycle. A thermal power station is a power station in which heat energy is converted to electric power. In most of the places in the world, the turbine is steam driven. Water is heated, turns into steam and spins a steam turbine which drives an electrical generator. After it passes through the turbine, the steam is condensed in a condenser and recycled to where it was heated. This is known as a Rankine cycle.
History of thermal power plant.
Friends, my name is Hunk and I am going to tell you the history of thermal power plant. The development of the steam turbine in 1884 provided larger and more efficient machine designs for central generating stations. By 1892, the turbine was considered a better alternative to reciprocating engines. Turbines offered higher speeds, more compact machinery, and stable speed regulation, allowing for parallel synchronous operation of generators on a common bus. After about 1905, turbines entirely replaced reciprocating engines in large central power stations.
Components used for thermal power plant.
Many components used for thermal power plant. Let's start with one by one.
Boiler.
A boiler is a closed vessel in which fluid, generally water, is heated. The fluid does not necessarily boil. The heated or vaporized fluid exits the boiler for use in various processes or heating applications, including water heating, central heating, boiler-based power generation, cooking, and sanitation.
Steam turbine.
A steam turbine is a device that extracts thermal energy from pressurized steam and uses it to do mechanical work on a rotating output shaft. Its modern manifestation was invented by Sir Charles Parsons in 1884. Because the turbine generates rotary motion, it is particularly suited to be used to drive an electrical generator. About 85% of all electricity generation in the United States in the year 2014 was by use of steam turbines.
Superheater.
Thermal power stations often have a superheater section in the steam generating furnace. The steam passes through drying equipment inside the steam drum onto the superheater, a set of tubes in the furnace. Here the steam picks up more energy from hot flue gases outside the tubing, and its temperature is now superheated above the saturation temperature. The superheated steam is then piped through the main steam lines to the valves before the high-pressure turbine.
Steam condensing.
The condenser condenses the steam from the exhaust of the turbine into liquid to allow it to be pumped. If the condenser can be made cooler, the pressure of the exhaust steam is reduced and efficiency of the cycle increases.
Reheater.
Power station furnaces may have a reheater section containing tubes heated by hot flue gases outside the tubes. Exhaust steam from the high-pressure turbine is passed through these heated tubes to collect more energy before driving the intermediate and then low-pressure turbines.
Cooling tower.
A cooling tower is a heat rejection device that rejects waste heats to the atmosphere through the cooling of a water stream to a lower temperature. Cooling towers may either use the evaporation of water to remove process heat and cool the working fluid to near the wet bulb air temperature or, in the case of closed-circuit dry cooling towers, rely solely on air to cool the working fluid to near the dry bulb air temperature. Common applications include cooling the circulating water used in oil refineries, petrochemical and other chemical plants, thermal power stations, and HVAC systems for cooling buildings. The classification is based on the type of air induction into the tower. The main types of cooling towers are natural draft and induced draft cooling towers.
Electrical generator.
A generator is a device that converts mechanical power into electrical power for use in an external circuit. Sources of mechanical energy include steam turbines, gas turbines, water turbines, internal combustion engines, and even hand cranks. The first electromagnetic generator, the Faraday disc, was invented in 1831 by British scientist Michael Faraday. Generators provide nearly all of the power for electric power grids.
ID fan.
ID fan is basically mentioned here for induced draft fan, and ID fan is always located between dust collector and chimney. ID fan will take the hot flue gases from furnace via dust collector and will deliver to chimney. ID fan will handle the flue gases, that is hot air. ID fan will produce the pressure lower than the atmospheric pressure in the system, or we may say that ID fan will produce the negative pressure in the furnace to remove the flue gases from furnace via electrostatic precipitators and to push the flue gases to chimney.
FD fan.
FD fan, which is mentioned here for forced draft fan, is used basically for providing the required quantity of hot air to the furnace for smooth and uniform combustion of fuel. FD fan will produce the positive pressure inside the system, that is furnace.
Chimney.
A chimney is a structure that provides ventilation for hot flue gases or smoke from a boiler, stove, furnace or fireplace to the outside atmosphere. Chimneys are typically vertical, or as near as possible to vertical, to ensure that the gases flow smoothly, drawing air into the combustion in what is known as the stack, or chimney effect. Friends, thank you for watching this video. Please like the video and share it with your friends.